So like we said in the previous video, J.J. Thomson discovered the electron and came up with this new model of the atom that incorporated that in, called the plum-pudding model. Another scientist then called Rutherford came along to test that theory, see if it was correct, and if it's not, make adjustments to it. And this is the apparatus he used. Now, this will actually make more sense by the time you've got all the way to the end of this unit, because this actually uses some stuff. It's quite strange that the first thing they use here is something they didn't understand back then, but doing this experiment allowed them to do other experiments that then allowed them to come back to this experiment and understand it even better. We'll explain that in a little second. But essentially, we want to know what the inside of an atom looks like, and there's no microscope powerful enough that we can actually see that as such. So what they did is a little bit like this. Let's say I have a cardboard box and I don't know what's in it. Okay, and the rules are I'm also not allowed to open it up. But either I know there is a small metal cube in it, or else there is a small metal sphere inside our box. Now, how I could kind of deduce which one of those two cases is true is I could get a machine gun over here that fires bullets through the box. Okay, and then if there is a wall a little distance behind the box, I can look at what happens to bullets, because those that don't come into any contact with the object will just pass straight through, and some of them might be blocked, those that come into the object. By looking at the pattern of the projectiles hitting the wall in behind, eventually I might be able to deduce that, okay, it's actually a cuboid that's in there, or maybe if I got different results, it's a sphere that's in there. Okay, so that's how I could do it with a box. However, we're dealing with something much smaller, so we can't use bullets. So what we do use is something called alpha particles. So rather than having a machine gun, we have what is known as an alpha source. Okay, an alpha source is just a little bit of material that emits these alpha particles. And what we know about these alpha particles, we use a little symbol like a little fish for them, is they are positively charged and they move really fast, and they're quite heavy. Okay, so we have these tiny little massive objects that are moving quite fast and that have a charge of +2. So what would happen with this is those alpha particles would be fired out in every conceivable direction. But what we do is we actually encase our little alpha source here, the source of those alpha particles, in lead with a little window, a little gap that they can get out, so that they only go forwards kind of along this line here. Okay, so what we in fact then get there is a fine beam of these alpha particles. And what we do is we fire them into atoms. Now we have an enormous choice of what atoms we could use, and what we use is gold. The reason we use gold is not because scientists have a lot of money. It's because gold is very malleable, and we can hammer it and hammer it and hammer it and make it so thin, it's thinner than even paper, so thin you could hold it up to a window and you'd be able to kind of see the light through it, that it's only a couple of atoms thick. And we need that because if you imagine doing this experiment, but you had not one box, but lots and lots of boxes stacked on top of each other, stacked, 100 deep and 100 wide, it's going to cloud your results a little bit. Really what we want is just a single layer of atoms if possible, or at least as close to that as we can. And to get that, we use our thin gold foil. So these alpha particles are going to be fired at the gold foil. They're going to encounter whatever structure it is those atoms have, and that's going to make them kind of move, okay, or deflect them in some way. Alpha particles are invisible, so we need some way of knowing where they go to. So what we have here is a little fluorescent screen. And what happens is when the alpha particles hit into the screen, they transfer their kinetic energy into light energy. Now, it means you get a tiny little spark of light almost. It's very hard to see, so we use a microscope to see it. These two things together, 4 and 5, or something called a scintillation viewer, just something that allows us to see that little bit of light. Now, we want the alpha particles to encounter atoms here and get deflected. We don't want them to encounter any other atoms, so this whole thing can't be done in air. We need to actually take all the air out of that region, so we need to make it a vacuum before we do the experiment. And what they did is this little fluorescent screen and microscope could be moved around so you can look in it from lots of different angles and see, okay, how many of these alpha particles went straight forward and we'd hit into it once in this position, how many were deflected out here, and we can then move our little viewer around to this position and see what angles were the alpha particles deflected by. Okay, now the plum pudding model would make a prediction as to what we should see in our results, and the idea was they would take the results and then compare them. So in the next video we'll look at what the predictions from the plum pudding model would be.